Okay, the final holiday homework is the content of 7.6 in both the 2-unit and 3-unit textbook, which is parallel and perpendicular lines. This content goes through the fact that if you have a line which has a gradient of m, or m1 we'll say, that all lines that are perpendicular to it also have the same gradient. So these two lines, y equals 2x plus 1 and y equals 2x minus 3, they are parallel to each other. And you can have a look at the next line. So we have y equals 2x plus 1. So that's 1 going across 1 up 2, starting at 1 and up 2, and 2, down 2, down 2. We drop that in there. This line going up here. Okay, that's line y equals 2x plus 1. And the other line I wrote down was 2x minus 3. So starting at minus 3, we go stepping across, so minus 3 there. Step up, going 1 across 2 up, the gradient each time 1, 2. So going 2 and going back. So bring those together like that. This is the line y equals 2x minus 3. And we can see that they are clearly parallel because they share the same gradient. So if m1 equals m2, then the lines are parallel. The condition for perpendicular lines is that, oops, sorry, that's the last lesson, that if m1 times m2 equals -1, then m1 is perpendicular to m2. So if I have a gradient, first gradient here of equaling 2, then the gradient of the perpendicular line, which just from terminology, a perpendicular line is called a normal. So a normal line, it means a line which is perpendicular to the first, and it's often m with equal n at the bottom, so that means the gradient of the normal. Now, the gradient of the normal, if m1 times m2 equals -1, then m1 would equal -1 on m2, which means that we take the original gradient, we reciprocate it, so by turning it upside down, so it's 1 on 2, and then we make it negative, we negify it. Okay? So these two gradients here are at right angles to each other. So another example of that, once again, I should have that before. If I have a gradient, the original gradient of being 3, then the normal's gradient, the gradient which is at right angles to it, is -1 on 3. If the original gradient was equal to 4, then the gradient of the normal, the perpendicular, would be -1/4. If the original gradient was equal to 2/3, then the gradient of the normal would equal, the reciprocal is 3 on 2, and the negative. If the gradient was already negative, so -1/2, then the gradient of the normal would be, turning it upside down, would be 2 on 1, and negify the negify, so it becomes 2. Okay, so it's all we need to do is use all this content with some examples. So if we have, find the gradient, so find the equation of a line parallel to y equals 2x plus 3 through the point, and we'll make it 5, 7. What is this equation? So here we have a line which is 2x plus 3, so it's like that. So that's the line. We want a line which is parallel to that going through 5, 7. So let's put that as 5, 7. And we want the equation of the second line here. Okay? So if it's parallel, then the gradient of the second line will have to gradient. So let's try to bring m. The gradient of the second line will have a gradient of 2. And all we need to have now is we want the gradient of 2 and we want 0.57. So we've met this in our last lesson in 7.5. We now use the y minus y1 equals m x minus x1 and replacing these values. So we get y minus, in this case it's 7, equals 2, which is the gradient, on x minus 5. Expanding that out now, you get y equals 2x minus 10, and now I'm going to bring the 7 across to the side, and you get plus 7, so y equals 2x minus 3. Okay, so my diagram is slightly skewed. If I want to find the equation which is perpendicular to y equals 3x minus 6, but also passes through negative 1, 5. So let's look at a diagram of that. 3x minus 6 is a steep line going through minus 6. And we want a line which is perpendicular to this, so it's going to be at right angles. Okay? That passes through negative 1, 5. So we want the equation of this red line here. Okay? So because we've given the formula as the formula of the original line, we want to find the formula of the perpendicular line. So the original gradient is 3. Therefore, the normal gradient, the gradient of this one here, the normal gradient, would equal upside down of that and negative 1/3. And once again, we've already got the point that we have there. So we can use y minus y1 equals mx minus x1. And placing in the numbers now, we get y minus, now y1 is 5, n is negative 1/3, and x minus negative 1. The two negatives will cancel for positive. Now, because we've got a fractional gradient, it's probably best to place this into general form. So multiplying throughout by 3, we get 3y minus 15 equals x plus 1, sorry, negative x plus 1. And bringing it over, you get x plus 1 plus 3y minus 15 equals 0. And then you get x plus 3y minus 14 equals 0. So that's two examples where you'll have to get your answers. So having a look at what you're going to be asked to do in your book, the first part is simply practice, drill and practice. So question 1 there. Don't forget, and I'll keep on reminding you of this one here, where you have angles that the angle, just go through there, that the gradient, I'll keep on doing that, where is it again? The gradient, got it, m is equal to tan theta. So here, with an angle of 30 degrees, that means that the gradient would equal tan 30. This is an exact value, so it's 1 on root 3. So don't forget that when you're doing that. Okay. The rest of the questions are over here. Okay. It says, show that they are parallel. If you don't need to show that something is parallel, please set it out nicely, but you need to show that the gradient of line 1 must equal the gradient of line 2. If you want to show that something's perpendicular, you find the gradient of line 1, so m1, and you times by m2, and it will equal negative 1. Okay? So have a go at doing that, and I hope you are successful.